Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving systems of three equations using matrices. Now, to do this, I will be using the Desmos Matrix Calculator. If you have some other type of calculator, you will have to look up your directions for using these matrices on your particular calculator. So let's start off with what a matrix is. So a matrix in math, it's just a rectangular arrangement of data. We can use matrices to represent systems of linear equations. Now, the dimensions of a matrix indicate its size and structure. The first number represents the number of rows, and the second number will represent the number of columns. And it's written in the form of row by column, such as a 3 by 4 matrix. Now, the data contained in each spot in a matrix is called an element of the matrix. Now, we have a special type of matrix we're going to use today to solve systems, and it's called an augmented matrix. And an augmented matrix represents a system of equations written in standard form. It includes the variable's coefficient in the first three columns and the constant term in the final column. So let me show you an example of what an augmented matrix would look like. In example 1, it says rewrite the system as an augmented matrix and state its dimensions. So in problem A, we have a system of equations, a system of two equations and two unknowns. So our augmented matrix, we use brackets to indicate it's a matrix. And then in the top row, we use our coefficients of x and y, 2 and 5, and then our constant term, 3. For the bottom row, our coefficients are -1 and 2. Our constant term is 4. And then we draw a little line to separate the coefficients from the constants. And this is said to be a 2 by 3 matrix because it has 2 rows and 3 columns. In problem B, we have a system of 3 equations. So I'm going to draw a bigger bracket here. And our coefficients of my top row are 3, 5, and -1. My constant is 10. In the second row, I have 1, 4, 1, and 7. Now, you've got to be careful in the bottom row because we're missing a term. The coefficient for x is 9. The coefficient for y is 0 because we're missing the y term completely. The coefficient for z is 2, and our constant term is 1. So this is called an augmented matrix, and it's a 3-row by 4-column matrix. All right, example 2. Write the system below as an augmented matrix, and then use technology to solve. So in our first row, we have -2x plus 3y minus 3z equals 13. In our second row, we have 3x minus y plus 2z equals -16. In our third row, we just have y equals 6. So I need to rewrite this so that all of my variables are present. So I'm going to say 0x plus 1y plus 0z is equal to 6. So I just rewrote that third row with all the missing terms. All right, now we're going to write our augmented matrix. For the top row, my coefficients are -2, 3, and -3, and my constant term, 13. For my second row, my coefficients are 3, -1, 2, and a constant term of -16. For the bottom row, 0, 1, 0, and a constant term of 6. Now, I'm going to enter this matrix into my Desmos Matrix Calculator. So to do that, I press the New Matrix button, and then I have to tell the calculator what size this matrix is. And it is a 3-row by 4 columns. So I set up the size. Now, very carefully, I'm going to enter each coefficient. So -2, side arrow, 3, side arrow, -3, side arrow, and my constant term, 13. All right, side arrow, 3, side arrow, -1, side arrow, 2, side arrow, and then my constant term, -16. first row, we have a 0, side arrow, 1, side arrow, 0, side arrow, and 6. Now, to get my answer, I'm going to press the enter button, which is this blue button at the bottom right corner. And when I do that, there's some new buttons that pop up. We're going to use this one, RREF. It stands for Reduced Row Echelon Formation, but you don't really need to know that. You just need to know that you're going to press that button and then push the name of the matrix you just made. So it was matrix A. Now, when you do that, the 3 numbers in the last column are your solutions. So in this problem, x was equal to -8, y was equal to 6, and z was equal to 7. So there's the solution to your system of 3 equations. All right. Example 3. If the solutions to the system below can be written in the form x, y, z, what is the value of x plus y plus z? So let's start by making sure our equations here are all written in standard form. Our first row says x equals 3z minus 5. So the 3z is on the wrong side. So I'm going to rewrite this x, and I'm going to put a 0 for the y because we don't have a y, and then minus 3z. The reason I'm putting it as negative is because we had to move it to the left side. And then that is equal to -5. In my second row, I have 2x. I need to take this y and move it to the left side, so that would make it -1y plus 2z, and that is equal to 16. On the bottom row, I have 7x. The 3y is on the wrong side, so I need to move it to the left side and put it as -3y minus 5z is equal to the constant term of 19. All right, now we have our equation set up in standard form. We're ready to create our matrix. So my coefficients will be 1, 0, -3, -5, 2, -1, 2, and positive 16, 7, -3, -5, 19. All right, now what I'm going to do is I'm going to use the same matrix that I used in my first problem. I'm just going to edit all my entries. So I'm going to change this -2 to a +1, side arrow 0, side arrow -3, side arrow -5, side arrow +2, -1, 2, positive 16, side arrow 7, -3, -5, side arrow 19. All right, so my solution for this matrix is 4, -2, and 3. But this problem did not ask me just to find the solution. It wanted to know what is the value of x plus y plus z. So I want to take 4 plus -2 plus 3. So that would be 2 plus 3, which would be 5. So x plus y plus z equals +5. All right, now let's get into some real-world problems. In example 4, it says the student council sold flowers for the Sweetheart Dance as a fundraising project. They sold 200 flowers that included carnations, roses, and Gerber daisies. The carnations sold for $1.50 each. The roses sold for $3.75 each. The daisies sold for $2.25 each. Most of the order was carnations, and there were 20 fewer roses than daisies. The total flower sales came to $453. How many of each type of flower was ordered and sold? So in this problem, I'm going to let x equal the number of carnations, because that was the first one they mentioned, The second flower they mentioned was roses, so I'll let y equal the number of roses. And the last one they mentioned was the daisies, so I'll let z equal the number of daisies. Now, just like in a normal system of problems that we're doing, like a coin problem or a ticket problem, we want to write an equation for the total number of flowers. So here, the number of carnations, x, plus the number of roses, y, plus the number of daisies, z, has to add up to a total of 200. Now we're going to write an equation for the value of each flower. So let's see. It said the carnations were $1.50 each, so 1.5x. The roses were 3.75y, and the daisies were 2.25z, and the total of the flowers came to $453. Now, this next equation is the one people have the most trouble with. Let me underline where it's going to come from. There were 20 fewer roses than daisies. Well, what I want you to notice is that it said the word roses first. So I'm going to put roses, the variable that stands for roses is y, so I'm going to put y equals. And it's 20 fewer roses than daisies. So daisies was z, and we want 20 fewer than that. So it would be minus 20. All right, now I'm going to have to put that last equation in standard form in order to make an augmented matrix. So I don't have as x, so 0x plus 1y. Then I have to move the z to the other side, so that's going to become minus 1z is equal to negative 20. All right, now we're ready to set up our matrix. 1, 1, 1, 200. 1.5, 3.75, 2.25, and 4, 5, 3. And then our last row, 0, 1, negative 1, and negative 20. All right, now I'm going to come back. I'm going to just edit my original matrix here. We have 1, side arrow, 1, side arrow, 1, side arrow, 200, side arrow, 1.5, side arrow, 3.75, side arrow, 2.25, side arrow, 4, 5, 3, side arrow, 0, side arrow, 1, side arrow, negative 1, and negative 20. All right, so my first answer, the number of carnations sold was 88, 46 roses, and Z was daisies for 66 daisies. All right, example 5. A theater has a seating capacity of 900 and charges $2.50 for children, $4 for students, and $5.50 for adults. So I'm going to stop right there, and I'm going to let X be the number of children. I'm going to let Y equal the number of students, and Z equal the number of adults. All right. Let's see. At a certain screening with full attendance, there were half as many adults as children and students combined. The total money brought in was $3,825. How many children, students, and adults attended the show? So, just like a ticket problem or a coin problem, we always want to start by writing an equation for the total number of things we have. So in this case, the number of children tickets sold plus the number of students sold plus the number of adult tickets sold added up to 900. Now we'll write an equation for the value of each one. So what did they say? They said children was 2.5x, students were 4y, and adults were 5.5z, and that brought in a total of $3,825. Now again, just like our last problem, the third equation is usually the hardest to get. So let me highlight where it's going to come from. There were half as many adults as children and students combined. So I want you to notice they said the word adults first. So I'm going to put Z equals. And I want half as many children and students combined. So that would be 1/2 parenthesis y. Wait, I'm sorry, children were X and students were Y. So half the children plus the students combined. Now I'm going to rewrite that. Z equals 1/2 X plus 1/2 Y. And then I'm going to even put it in standard form because I need to move the X and Y to the other side. So this would be negative 1/2 X minus 1/2 Y plus Z is equal to 0. All right, now we're ready to make our augmented matrix. 1, 1, 1, 900. 2.5, 4, 5.5, 3, 8, 2, 5. Now, for this negative 1/2, I'm going to put negative 0.5, negative 0.5, 1, and 0. All right, now we're ready to make our matrix. What happened? I lost it. I want Desmos Matrix Calculator. All right, we got it back. All right, new matrix, A. It's a 3 by 4 matrix. So 1, 1, 1, and 400. Side arrow. 2.5 side arrow. 4 side arrow. 5.5 side arrow. 3, 8, 2, 5 side arrow. Negative 0.5 side arrow. Negative 0.5 side arrow. 1 side arrow and 0. Now I'll hit the return symbol, and then I want this RREF, matrix A. All right, now I'm getting kind of a weird answer. So this tells me I have a sum error somewhere in my matrix. So let me go back and see. This 400 was supposed to be at 900. So if you're getting a weird answer, you probably just made some kind of typo. So now I can see that there were 150 children, 450 students, and 300 adults attended the show. All right, last example. Courtney has a total of 256 points on 3 algebra tests. Her score on the first test was 6 points higher than the second test. Her total score before taking the third test was 164 points. What were Courtney's test scores on the 3 tests? So I'm going to let X equal the score on test 1, Y to be the score on test 2, and Z can be the score on test 3. Now I know she has a total of 256 points, so X plus Y plus Z equals 256. Now let's see what else I know. Her score on the first test was, so X equals 6 points higher than the second test. So the second test was Y, and we want 6 more than that, so plus 6. All right, our next information says her total score before taking the third test was 164. So I know the first test plus the second test was equal to 164. All right, let's make our augmented matrix. 1, 1, 1, 256. Now be careful on the second row. We have 1x. We need to move that y to the other side, making it negative 1y. We're missing a z, and that's equal to 6. Our third row, we have 1x, 1y, 0 z's, and 1, 6, 4. All right, now I'm going to edit matrix 1 because 1, 1, 1, and I want this first row to be 256, side arrow. 1, negative 1, 0, and 6. Bottom row was 1, 1, 0, 1, 6, 4. All right, so her first test was 85, her second test, 79, and her last test, 92. And that concludes today's lesson, solving systems of 3 equations.